Now, in this video, we will going to discuss about how to solve the problem on shortest distance in third quadrant. So here, a point capital G is 25 mm below HP and is situated in the third quadrant. Its shortest distance from the intersection of xy and x1, y1 is 45 mm. Draw its projections and find its distance from the vertical plane. So since he has given the problem is in the third quadrant, so naturally HP is here, VP is here, and then LPP is in here. So this is the three-dimensional picture. So wherein point G is 25 mm below HP, so we have 25 mm below HP. When you look from the front view, that image will going to fall on the vertical plane, where is that 25 mm from here to here is 25 mm, and is situated in the third quadrant. So below HP, and we have to have behind VP, but we don't know what is the distance behind VP, so we need to find out that. And then, but he says that the shortest distance from the intersection of xy and x1, y1 is 45 mm. So which direction I should look? So since it is the third quadrant, it is behind VP, so obviously behind LPP. So behind LPP will come only when you look from the left side view. So when you look from this left side view, the point is behind LPP, and the distance behind LPP is seen in both VP and as well as in HP. But he has not given that distance, which is how much the distance behind LPP is. So we can take whatever distance we want. But we can see the shortest distance. So from the intersection of xy and x1, y1 line. So this is the xy line and this is the xy line. The shortest distance is this distance, which is 45 mm. So from the intersection of xy, so this is the 45 mm. So when you look from the left side view, we can see the distance from here to here, which is the 45 mm. So that distance is from here to here. So when you look from the left side view, we can see directly here. So you will going to get G double dash. How do I get that? Because G dash and G double dash both will going to lie on the same line. So once you get this distance, so we know that once you get this distance, so naturally we can able to get this distance. How? The distance below HP is seen in profile plane, and also the distance behind VP can also be seen in the profile plane. So this distance is known. So this distance is known, and this distance we need to find out. Therefore, this distance is below HP. So we know below HP, we know the shortest distance. Therefore, we will be able to find behind VP distance. So when you cut it and open, HP will go to the top and LPP will come to the left side, which is as shown. So the distance with respect to the profile plane can be any distance. So we can take any distance and then draw a vertical line. Then the distance below HP is seen in the vertical plane, that is this distance, which is 25 mm, which is given in the problem. So we take 25 mm from here and then draw a horizontal projector to the profile view. Then we know the shortest distance can be seen in the profile view. So from here you take a distance of 45 mm and cut an arc on this horizontal projector. So wherein you will go to get the P double dash. Then you project this line till here. Then draw a line inclined at 45 degrees. Then what happens behind VP, which is horizontal here, will going to become vertical here, which is behind VP. So then you draw a horizontal projector from here and draw a vertical projector from B dash. Both will going to intersect at this point. So we will going to make this point as small p. So this is how, and we will be able to find what is the distance with respect to VP. Then this will going to be the final solution what we have. So here you draw xy and x1, y1 line. As it says, it is in the third quadrant. So HP will be above, VP will be below, and LPP, this should be LPP, it is not RPP. So LPP will be on the left side. And then here the distance, you take any distance from x1, y1 line, and from xy line you measure 25 mm, you mark this point as G dash, and then draw a horizontal projector from G dash to the profile view, and take the radius of 45 and cut an arc on this horizontal projector. So wherein you will going to get G double dash, and draw a 45 degree line adjacent to HP, and then draw a vertical projector from G double dash to the 45 degree line. From this 45 degree line, you draw a horizontal projector and draw a vertical projector from G dash to the front view, top view, and both will going to intersect at this point. And then you measure the distance from here to G, which will going to be L, which will be 37.42. So this is how we will be able to find the solution for the distance of the point capital G is 37.42 mm from the vertical plane. It is behind VP. Now we will going to try to solve the problem by using the AutoCAD software. So first we will go to the AutoCAD screen, switch off the grid mode and switch on the ortho mode. Now we'll go for the limits command. First we're going to type limits, then specify lower left corner, by default 0, 0, and specify upper right corner. You take 297, 210. Then zoom all. Then go to line command, draw a line, take some arbitrary point and click on the first button of the mouse and drag the mouse to the right side. Take some distance and click on first button of the mouse. Again to the top side, take some distance and click on first button of the mouse, and then go to offset, take the distance as 297 and subtract the distance as 297 and select the vertical line and offset to the left side, and you click on the first button of the mouse. Since by default it is exit, you just press enter key. Similarly again, previous command is offset, so again you just press enter key and type 210 and then specify offset distance. You take 210, select object to offset, you take the horizontal line and offset to the top side, take the cursor just to the top of the line, above that line which you have been selected, then click on the first button of the mouse. Since by default is exit, you just press enter key and zoom, extend and then zoom 0.6x. So that means 60% of the total display screen. Fillet, by default it is mode is trim and radius is 0. So you select this line and you select this line. So it will not only extends and trims the extra portion. Again you select between these two, you will get this. Again you select between these two, you will get this. Now we will just go to zoom window. Now we will going to type the problem. So to type the problem, so a point capital G is 25 mm below HP and is situated in the third quadrant. Now we'll go for D text. So here specify start point, take the height as 4, then rotation angle as 0 and put the caps lock off. Type the problem number 17. A point capital G is 25 mm below HP and is situated in third quadrant. Then and below HP and is situated in the third quadrant. Its shortest distance from the intersection of XY and X1 Y1 is 40 mm, 45 mm. Draw the projections and find its distance from VP is 45 mm. Draw its projections and find its distance from VP. Then enter. So now we have the problem. Once you find the problem, now we will going to set the layers now. First we will go to layer, set the layer as, create the new layer as XY and press enter key. Then click on this, take the layer as front view, enter, click on new, type the layer as top view, enter, type the layer as side view. Now we will go for layer 0, set the line weight as 0.05 because that is the projector line. XY line has to be 0.13. So take 0.13, okay. The front view should be having magenta color, accept. Then the top view should have red, select this, and the side view should have the color as blue and say okay, and finally close it. Now we will going to draw this solution. So where is the solution? The solution is here. First we will go to draw the XY line and X1 Y1 line and identify the planes. To do that, first we'll go for a line command, draw a horizontal line of any distance and similarly draw a vertical line of any distance, and then first you identify the planes, go to D text, select from arbitrary point, take the distance height as 3, rotation angle as 0. So mark this as HP and you mark this as VP and you mark this as LPP. You have not given which profile view, So we can take whatever we want. As the distance is not given with respect to the profile plane, you take some arbitrary point and drag the mouse and downwards and click. Again take some distance and click on first button on the mouse. Then go to offset, take the distance as 25. You select this XY line and offset it. Then go to circle, take int of this, take the radius of 45, you take this. So here what I have done is I have drawn this point now. So once you do that, now we will go for a break this circle in anti-clockwise direction. Then again you break this on this anti-clockwise direction, and then go to erase this line, and then go to fillet between these two. Then go to line, take int of this and take at the rate 100 less than 135. Then go to line, take int of this and drag a horizontal vertical line. Again you take line, select from this point and take perpendicular to this, and then go to fillet between these two and fillet between these two. Now once you do that, then go to break this line till here, then you 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 break this line till here. So now we have fillet between these two. Once you do that, then go to zoom window, select this. So go to donut, take it as 0, it has 3 outside diameter, take intersection part of this and take intersection part of this and take intersection part of this. So now we have completed all these things. Then go to dtext, specify start point, you select some arbitrary point, take the height as say 3, rotation angle as 0, type this as xy, then you mark this as x1, then you mark this as y1, then you mark this as small g, you mark this as g dash, and you mark this as g double dash. Then go to move, switch off the ortho mode, you take x1, keep it here, then horizontal plane, then vertical plane, then LPP. So first you do this, then go to y1, then xy, adjust this. So go by periodic, you don't just take any arbitrary text and then do it. So you do it in a very methodical way, so that you will not going to leave any of these things. Then once you do that, now we will go for DDIM, then go to modify, set the dimensioning variables. So what is the offset from the origin? You take it as 2, then go to lines and symbols, you take the arrow size as 3, then by default text height as also 3, then align with the dimension line, centered becomes above, then offset from the dimension line as 2, then take the primary units, make this as 0 linear dimension, say OK and say close. Now once you do that, then go to dim, then go to center of this and then intersection point of this. So we're going to get it as 25. Then we want align dimension, so you just go to center of this and take int of this, and you are going to get it as radius 45. Then once you get this, so then angular, select this line and you select this line, so you're going to get it as 45 degrees. Once you get this, now we need to find out this, then go to center of this and take int of this. So you just take this point, go to text, so enter dimension text, give space, enter, so you're going to get this. So here you're going to get this point. Now we need to check what is the dimension. So I'll go to DDIM, DDIM, select this, DDIM, select this, go to modify, select this primary units is a 0, make it up to decimal point, so click OK. So you're going to get this dimension now. You just go to distance, take center of this, take INT of this. So what will going to be the dimension? You're going to get it as 37.42. So actually in your problem also we are getting 37.42. So this is how you will be able to get the answer. Now here first you just go to DDIM and now you go to modify, go to primary units, make it this as 0. So you're going to get this. So automatically everything will going to be updated. Now we need to change the layers now. So to change the layers, you will just click on this and you just click on this, go to CH, go to layer, make that layer as XY. Then once you do that, now you take top view, this, go to CH, make the layer as top view, select this, then you select this and select these two, go to CH, go to layer, make this layer as front view. So now accordingly all these things which will going to be changed here. Then again you just click over this and then you take this, go to CH, go to layer, make this layer as side view. Once you do that, now we will going to have the projections. So go to leader, LEA, take the nearest point, you select this point and put on the ortho mode, click on this, go to annotation, option, none. Then again go to leader, nearest point on this, go to annotation, option, none. Then again go to leader, take nearest point on this and you take this annotation, option, none. Then go to explode X. So these are the 3 lines which you know because this is a block. So I'm exploding that. Then go to erase, erase this line, erase this and erase this. Once you do that, now we'll go for D text. Now you take this height as 3, rotation angle as 90. So go to text, you type L equals question mark and then it will automatically comes with this. Now we need to write the answer. So to write the answer, so here I will just come over this and go to D text and here I will write answer, all are capitals, sorry. Then go to D text, select this, rotation angle of text as 0. So go to answer, type answer, then again go to D text. So here again L equals 37.42 mm. So this will going to be your final answer for this particular problem. So now we will go try to compare that with the already which you have written in the what you get already. So you will just come down to this and you check answer is equal to L is 37.42. So the same dimension we are able to get it here also. So then I will just put it into the box and these are all just the aesthetic appearance. If you want you can do it, otherwise we can leave it, there is no problem as such. So but what I need is the answer should be up to the second decimal point. So this is how we will be able to solve the shortest distance problem in the third quadrant. Thank you.